This is the part 2 of the world's longest subsea pipeline video series. The template has been successfully placed from 100 meters above on a rolling sea. The next step is to tap the gas field. It takes 2 years to drill the first 8 wells, and they must have them ready to go before the pipeline can be connected. A specialized drilling ship is moved into position over the top of the gas field. Watch to find out more.
A specialized drilling ship, the West Navigator, is moved into position over the top of the gas field. The Ormen Lange gas wells will be the largest deep-water wells drilled in the world. They drill the field with a powered drill head operated from the ship. Once assembled, the pipe is lowered through the bottom of the ship and the 1,000 meters to the template. From here, the drill head moves another 2,000 meters through the seabed to the gas deposit. And then it snakes its way through the gas pockets. Every step of the way is monitored and recorded in a virtual database, which keeps expanding and is used by the engineers and surveyors to plot the next drilling spot. Back on land, the team can enter the cave, an amazing 3D undersea world. By virtually passing over the seabeds and the gas find, they can locate the most promising parts of the deposit. Jens Grimsgaard can plot the drill's movement from the cave.
With a joystick, I can also fly in this world by just using it, this tip here, and using my movements of my hand to steer myself through this reservoir.
During the drilling, data collected by the drill is sent back in real time to this database, which is constantly being updated. The computer generates the images, which puts the team right in the gas deposit. They pinpoint spots from 10 kilometers away with astonishing accuracy.
That would be compared to that your dentist would be in the 10th floor, and you would be situated in the first floor, and he's going to fill out one of your tooths back there. We're getting extremely good results by doing this.
The template gets its power from the land through a 125-kilometer control cable called an umbilical. This cable carries huge amounts of electricity, enough to power 20,000 homes. Combined in this umbilical cable are tubes carrying hydraulic fluid, fiber optics, and electrical cables. The welds on these tubes have to be as strong as the welds on the pipeline. This is the power and control connection to the template. Without this, the template will be just 1,000 tons of useless metal at the bottom of the North Atlantic. But how do they deal with a cable that is a staggering 125 kilometers long? The cable is built in a factory right on the dock. As the cable is made, it is fed onto a giant spool on the deck of the Scandi Neptune. Once the 120 kilometers of continuous cable is spooled up, it will head out to the Ormen Lange gas field to connect the control room to the 4 underwater templates. But now, they have to prepare the seabed. The bottom of the ocean under the North Sea is a treacherous place. And, as you're about to discover, the engineers building the world's longest underwater pipeline are facing a mountain of trouble. 8,000 years ago, 2 pieces of Norway, each about the size of the island of Tobago, slid into the sea, causing a mega tsunami. The landslide, known in Norwegian as the Storega, created a huge shelf in the ocean's topography. The Ormen Lange gas field is on the edge of the Storega, locked inside the huge depression left behind by the slide. This underwater disaster created a mountainous seabed with peaks that rise between 25 to 55 meters. But the biggest concern for Hydro is how to get the pipeline up the Storega slide face, a whopping 300 meters. That's nearly as tall as the Empire State Building. Underwater surveys reveal a rugged and fractured seabed, but the unstable sediments have long ago disappeared. The rock is more than stable enough, and it would take a new ice age to dismantle it again. But the study has made them more aware of the seabed and the pathway they will need to clear for the pipeline that will connect the underwater gas rig to the land. First, they must build a 3D model of the sea floor and find the easiest route. What they have created is a virtual reality program With this model, the engineers are able to plot the best pipeline route. The fisheries in the North Sea is a huge industry, and Hydro has to make sure the pipeline will not damage the reefs where the fish feed and the fishing boats work. But the concern is not just about the environmental impact at sea, but also on shore, where one of the largest gas plants in Norway is being built. The land connection they have chosen is the small island of Gossen and the tiny community of Nyhamna. The destiny of this quiet community will be forever altered now that it's been chosen as the landing area and processing plant for the Ormen Lange gas project. What was once a remote corner of Norway is being transformed into the bustling industrial center of the Ormen Lange gas project. Here, the raw gas from the Ormen Lange gas field will be converted into usable fuel. But to do that, over 2 million cubic meters of rock is being carved from the island, and over 30,000 tons of steel brought in. Almost overnight, what was once a small village has become the busiest construction site in Norway. Over 2,200 workers are on the job site each day to keep this mega gas plant rising from the rocky coastline. There's a canteen to feed 1,000 people in a city. Each night, the workers retire to the hotel, which will provide 1 million guest nights over the course of the project. But it will be removed when the processing plant is up and running. Three-dimensional models of the plant have been built, and the engineers walk through it in virtual reality before and during construction. Every bolt, I-beam of steel, is pre-visualized. Because of the volatile gas, the specifications have to be executed perfectly. But the plant has been built for efficiency. The raw gas travels through the pipes and is converted into usable fuel in a mere 10 minutes. That's a blink of an eye in this business. Then it will be ready for delivery to the UK. The gas processing units are delivered to the island by ship. Cranes offload the components onto this massive flatbed transport. This remote-controlled monster has 48 independent axles and 96 wheels. It expertly shuttles the thousands of components needed to build the plant. Here on land, the workers have a close working relationship with the job site. But offshore, the workers hand in their wrenches for what else? Joysticks. Offshore, the underwater work is done with remote-operated vehicles, or ROVs, from pipe laying to heavy lifting. And that requires a lot of different ROVs and people who can operate them. In this warehouse is a simulation tank built just for offshore personnel to train on ROVs. It's driving school for robot jockeys. Here, they simulate projects that will take place offshore. It takes special tactile skills to maneuver a crane arm from 1,000 meters away. Multiple cameras allow the operators to see the action. After the intense training with the ROVs, they're sent offshore, where the stakes are high and it's no longer a game. There are no second chances. This is the Pipeline End Termination Unit, or PLET, a big machine for one simple task. It connects the underwater template, or gas well, to the Ormen Lange pipeline. But it's never that simple. At 35 meters long and 30 meters wide, this 350-ton device is being lowered the 1,000 meters to the sea floor. Now that the PLET is on the sea floor, they assemble its components. Called modules, these components make the crucial connection between the template and the pipeline that feeds gas to Nyhamna. All the connections at this depth are made with ROVs. But they can't do any of this work without first testing the systems. Thomas Berndt is the Subsea manager.
We are testing and testing and testing here, and when we leave this hall, We are 100% sure that this connection will be tight when we come offshore. There won't be any leakage. A leakage offshore at 850 meters with large volumes of gas is a disaster, which we have to avoid.
They practice lowering the modules and testing the connections, which will be handling 70 million cubic meters of gas each day. They're training with an exact replica of the one that's on the sea floor. It's a large investment, but money well spent. Surrounding the connection module is a steel cage that protects it from stray objects that could drop off the drill ships and fishing trawlers. When the gas exits the field, the steel pipe expands. A little bit of expansion is okay. But the reason they're going to this much trouble is they expect the Ormen Lange pipeline to expand along its entire length by as much as 1 meter. And that's enough to rip it apart. So they've solved this by using a connector that slides back and forth on rails. It absorbs the pipe's movement and keeps the gas flowing. Meanwhile, the engineers are tackling the Storegga slide and trying to get the umbilical cord, or control cable, run from the template to the control center, 120 kilometers away. But to do this, they have to find a way through the rough and tumble terrain left in the wake of the slide. The solution is to build an underwater excavator, agile and strong enough to handle the job. It's a daunting prospect. That is, until they built the Spider. The machine that inspired this one was originally built for the Swiss forest industry. And like its Swiss cousin, the Spider moves along using powered tracks and articulated legs. Its mission is to excavate 6 trenches at water depths up to 1,000 meters. The biggest of them is a 4-meter wide by 4-meter deep monster trench, big enough to drive a truck through. One Spider is outfitted with a powerful shovel. It's strong enough to cast aside a 3-ton boulder. Instead of a shovel, the other Spider has a suction nozzle. Powerful water jets break up the sea bottom, and the nozzle sucks it up and fires the mud to the side. All the while, the Spiders will contend with slopes up to 35 degrees. There are sensors on all movable parts, connected through an umbilical from a support vessel, which floats above and monitors its progress. The umbilical carries power and control cables and lets operators manipulate the 6-meter-long Spider to within 10 centimeters of accuracy, 10 centimeters from 1,000 meters above. It's an unprecedented mobilization of such complicated and agile robots. In all, these 2 champion diggers managed to excavate 3,500 cubic meters of soil, creating a safe path for the gas pipeline. The Langeland, which runs 1,200 kilometers from Norway to the UK, is the largest subsea pipeline in the world. This job requires 1/3 of the world's combined pipeline production capacity. That's over 1 million tons of steel. The value of the pipeline contracts is an unimaginable $700 million. Langeland uses pipes over 1 meter in diameter, and each single piece of pipe has to be able to stand the enormous pressure on the sea floor for the next 40 years. The pipes are each 12 meters long and weigh 10 tons. Another 10 tons of concrete and metal is added to give them enough weight to stay on the ocean floor. A total of 100,000 steel pipes are needed to span Norway to the UK. That includes over 1 million tons of concrete and 25,000 tons of steel reinforcing. Robert Payne is the man responsible for the integrity of the pipeline as it's being assembled.
Each jointed pipe weighs about 20 tons, about 10 tons of steel, 10 tons of concrete. It's concrete and it's got inside of it a wire mesh foundation to help it stick together. So there's so much volume inside of it whenever it gets on seabed and it gets light of air, it wants to float, so the concrete keeps it situated on seabed.
Each of the 100,000 pipes is numbered as it comes out of the plant, destined for a specific location in the line.